My dear friends, you know the word bipolar. In case of a transistor, bipolar junction transistor. Actually, bipolar reflects the fact that holes and electrons participate in conduction in case of the transistor. I mean, both are responsible, electron as well as the holes. That I mean bi mean two, polar mean electron and hole. You know, a transistor is either NPN or PNP. NPN mean emitter, base, collector. You know, the first layer is emitter. Emitter layer is heavily topped. Base is lightly topped. And topping of the collector is less than that of the emitter. That means we cannot change emitter to collector or collector to emitter because both are of n type. And sometime it comes in our mind because both are n times and then can be replaced. No. Because emitter is first n section, which is emitter, it is always heavily topped. The outer layers mean n and n in case of NPN. The outer layers have width much greater than the sandwiched P or N type material. You know what the ratio of the total width to that of the central one. It is, 150:1. Mean if the total width is 150 of any unit is 150, then the central sandwiched will be only a 1. So this is the ratio. Now the topping of the semiconductor layer, the topping of the sandwiched layer is also considerably less than that of the outer layers. And typically it is 10:1, remember. Now what is the function of a transistor? The basic function of the transistor is to amplify the AC signal. Mean you are having input AC signal, a weak signal, varying, weak signal. Then it gives you a strengthened signal at the output. So basic function of a transistor is amplification. Maybe amplified signal is in phase or the out of phase, it is another thing. Too often it is assumed that transistor is a magical device that can raise the level of the applied AC input signal without the assistance of the external energy source, but it is wrong. Transistor amplifies the signal at the cost of DC energy levels applied at the emitter, base and collector. Okay? Or you can say the improved output AC power, mean you are giving a weak signal and getting the strengthened signal, that is the improved output AC power level. How? Is the result of the transfer of energy from the applied DC supplies. DC supplies mean DC biasing at the emitter, at the base and at the collector. Okay? Transistor needs some DC voltages at the base, at the emitter and at the collector. And you can say transistor works because of the DC biasing. You can say transistor needs the DC biasing for operation and then it works for the AC signals. The analysis or the design of an electronic amplifier therefore has two components, the DC portion and the AC portion. Now the important basic relation, what are the basic important relationships for a transistor? When the transistor is said to be in the on state means the active stage, okay? What is the on state? If you just note down from the characteristics curve, the current, there is a sharp rise in current, just crossing about 0.7 volt, there is a sharp rise in current. So just crossing 0.7, then we say the transistor, it is in the on state. Before 0.7, we are applying base emitter voltage, but the current is almost nil. It is almost zero. So just crossing 0.7, there is a sharp rise in current. And you note it down again, the emitter current is increasing along the y-axis, but they hardly change in the base emitter voltage. It remains approximately close to 0.7. Okay, so when the transistor is said to be in the on state, base emitter voltage will be always 0.7 volt. Okay, because it's quite close to 0.7 as the emitter current is increasing. But in the analysis, it is taken, base emitter voltage is taken as 0.7. Then the transistor is said to be in the active region, and mean the transistor it is working. Now then, how much emitter current is, that depends upon the, if you slightly increase the base emitter voltage, the emitter current go on increasing. Practically we say the base emitter voltage is around 0.7, and you can have any emitter current. The first equation is base emitter voltage is 0.7. Then, the amplifying principle of a transistor for common emitter configuration is the output current over the input current. That means IC divided by the IB. And that is, the ratio is called beta. Beta is IC over IB. Right? And, the collector current is controlled by the base current. Collector current is controlled by the base current, not the base emitter voltage. It is around 0.7 volt. So as base current controls the collector current, that's why transistor is called, the transistor is current controlled device. Transistor current controlled device because collector current is a function of the base current. Okay, now then there is another transistor equation that the emitter current is basically equals to the base current plus collector current, and collector current is written as beta into IB. Substituting the value of IC, beta, that means beta IB, the equation becomes beta plus 1 bracket close, within the bracket beta plus 1, then multiplied by IB. Now as beta of a transistor is very much large, beta is very strong, beta is good. So if beta is greater than 1, the 1 may be neglected as compared to the beta. So that becomes simply beta IB. And what is beta IB? It is IC. So IE approximately equals to IC. And one thing keep in mind, IC will be slightly less than IE, slightly less. And that depends upon the value of IB. So these are the basic equations to remember. It is called current control device. Bipolar mean electron and hole, they are responsible. Base emitter voltage, when the transistor is in the on state, it is close to, it remains close to 0.7 volt. And this is all. Thank you very much.